Hello, teacher. I am Musa. In this assignment, I implemented a level order travels for a binary tree in Java using the iterator design pattern. This technique allows traversing a binary tree in braided first manner, meaning the nodes are visited level by level, from top to bottom and from left to right. The project is divided into four well-defined classes. A three-node level order iterator, binary tree, and tree demo. Each of these classes plays a specific role and contributes to the overall modular and organized structure of the program. The aim of this task is to apply object-oriented programming concepts such as abstraction, enclave, encapsulation, modularity, and separation of corners, while also developing a clear and reusable travels method for binary trees. Three-node class. The three-node class is the most fundamental component of binary tree. It represents an individual node within the tree structure. Each node is capable of holding a single data element and maintaining reference to its left and right children. The structure of a tree is built entirely from these interconnected nodes. The data file stores the value as associated with that specific node. In our implementation, we use integers, but the class could be easily adapted to work with other data types using generics. Uh, the left and right files are referenced to the left and right child nodes respectively initially, but are set to null, indicating that the node has no children upon creation. The constructor of the class reserves an integer as an argument, which is the assigned to the data file of the node. The left and right child reference remain null until other nodes are explicitly connected to them. By using this class, we can build a hierarchical structure that models many real-world tree-like systems. Its simplicity and reusability are core advances in the data structure implementation. The complex constructor the constructor performs basic assignments with no loops or recursion tree flow, and the execution time is constant regardless of the size of the depth of the tree. Level order iterator class. The level order iterator class is designed to facilitate level order travels of binary tree. It uses the Java collection framework and specifically relies on a quine implemented to maintain the correct order of nodes for braided first travels. It imports assigned libraries such as iterator, linked list, and queue, enabling it to manage elements and traverse the tree efficiently. This class contains a private queue that temporarily stores and nodes in the order they should be visited. The constructor takes the root of the tree as a parameter. If the root is not null, it is added to queue, marking the starting point of the travels. The has next method returns a boolean value indicating whether a tree and any more nodes left to process in the queue. And the next method performs the equal travel step. It removes the from front node from the queue. It checks if the removed node has a left or right child. If so, it adds those children to queue. Finally, it returns the current node. This class enabling external code to iterate over the tree structure using a simple standardized approach. It hides the complexity of managing travels state and allows lines to access three elements in a linear and readable format. The complexity constructor one only the root node is added and no other nodes are possibility utility. Has next one it simply checks whether the queue is empty. Next one per node one in total. Each node is visit exactly on once and its children added at most once, so total operates graph linearly with the number of nodes in n. Binary tree class. The binary tree class serves as the container and manager for the entry tree structure. It defines the entry pointer to the tree and provides methods for access traverse logics. The class contains a private reference to the root node of type tree node. This encapsulation ensures that the root cannot be directly accessed or modified from outside the class. The constructor receives a tree node object and sets it as the root of the tree. The get level or the iterator. A method is a key utility provided by the class. It returns a level or the result with the tree's root that allows other classes to iterate toward the tree without needing to manage the travels logic themselves. By isolating the traverse logic inside the iterate class and offering it toward this method, binary tree maintains a clean and well structured interface. Time complexity. A constructor O1 simply async at root node. A get level order iterator O1 it constructs and returns an iterator without intending any travels or looping. Three demo class. The three demo class contains the main method, which is the starting point of the Java application. This class is the responsible for assembling the binary tree and displaying the level order travels. The main method creates a binary tree manually by instantiating three node objects and linking them. The structure includes a root node with value 1 and subsequent child nodes, forming a complete binary tree of three levels. A binary tree object is then created using the root node encapsulation the entire structure. The program then requires an level ordered iterator from the binary tree and uses a while loop to traverse the tree. During travels, each node's data is retrieved and printed in level order sequence using has next and next. And this class demo starts how to use the other classes together in a real world scenario and acts as the integral point for the whole exhibition. Uh, Time complexity tree construction or an edge node is created and connected explicitly once. Get level order iterator or one instance iterator. A travels loop or an visits all nodes in the tree. A consolation. In summary, this assignment allowed me to deeply understand in the logic and design behind three travels techniques, specifically level order travels, by dividing a referenceable across four separate classes, and I ensured that each component of the program is focused and maintainable and easily testable. Using the iterating pattern provide a clean interface for navigating the tree abstraction, away the eternal details and query-based logic. The, the time complexity of each operation has carefully constructed all correct times not creating iterating construction and travels around in linear or constrained time, ensuring the system remains efficient even for large trees. And throughout this exercise, I not only improved my ability to implement classic data structure like binary trees, but also gained valuable experience in applying object-oriented principles to the design modular and reusable code. The result is a fully functionality and scalable binary tree travels system that could be extended or adapted for future projects. This segment has greatly enhanced my knowledge of Java programming and deepened my approach for well structured code design.